Hello, and welcome back to Every Problem. This is Stewart Calculus, Chapter 2, Section 3, Problem 11. Here on this problem, we are using some algebraic techniques to find the limit at various points. And here what we can see is, if I were to plug in 5, trying to find the limit around x equals 5, well, we run into a little bit of a problem because the denominator goes to 0. In previous sections, we've made a table of values, such as your x and y values, and you find things close to 5, like 4.9, 4.99, 5.01, and so on and so forth. Here, we want to find a way to use a technique called direct substitution. And direct substitution you can use if you have a continuous function. Now, what does it mean for a function to be continuous? Well, it means that, in this case, we need the function to work within some set domain all the time. So what do I mean by that? Well, in this case, for it to be continuous, we need the function to not have any problems at all anywhere near 5. So we need it to be defined on all numbers around 5 at the very least. And so when we have these continuous functions, we can use this direct substitution, which means you just plug in 5 and that gets you your answer. Unfortunately, if we plug in 5, we get a 0 over 0 problem. So we have to do a little bit of work and modify the function to see what happens. So let's get started. We have limit as x approaches 5, as written above, right? Well, when I see x squared minus 6x plus 5, I know that this can be factored. So this can be factored into x minus 5 and x minus 1 all over x minus 5. Now, here's an important thing, is this was really confusing to me when I first learned limits, was because I didn't understand, wait a minute, how are we just plugging this number in to find the limit? I thought limits are what value is approaching. And here's basically how it works. A function such as this one, this x squared minus 6x plus 5 all over x minus 5, this is our function, and the function is a rule, okay? We are not changing the entire function just to make this, we're not technically just changing the function and calling it a day. What we're doing is we are modifying it using algebra in order to help understand, well, what happens around x equals 5. So that's the big idea, and I know it can be a little bit weird, but if you look, if we do some simple algebra, we find that the x minus 5s cancel, and we just get x minus 1. So what does this mean? This means that our function behaves like x minus 1 at all points except for x minus 5. So that means if I were to draw a graph of this function, let's see, x minus 1, so we'll put negative 1 down here. Our function basically behaves like this. And once we get to 5, there's going to be a hole in our graph. And then it keeps going. And so that's what happens here at this function. And what we're doing is we are algebraically modifying it so that we can use direct substitution to find what happens near 5. So we have essentially x minus 1. We plug in 5, so that gives us 5 minus 1. And our answer is 4. And so again, what does this mean, right? Well, it means the limit of this function that we started with, this x squared minus 6x, all of this, right? It means that as x gets closer and closer to that number, 5, then our output, our f of x, is going to approach the number 4. And that is what it means to have a limit. If you have any questions, or if there's anything that I explained maybe not so clearly, feel free to ask. I just wanted to go over all of this since this is the first limit problem that I'm doing on this channel. So definitely let me know, and good luck with everything else.